Good afternoon, everyone. Thank you for coming. My name is Pedro Machado. I'm the founder of 205 Data Lab. We're a boutique consulting company specializing in DBT and Snowflake implementations. I've been implementing DBT since 2017. It's been a great tool for our company and for our clients. And I'm here with Kiran Jain.
Hi, everyone. I'm Kiran Jain. I'm VP of Data at Metropolis Technologies. I was previously at Shopify and before that at Meta, where I led data engineering teams supporting product and analytics growth areas. So I took on this role about a year ago at Metropolis Technologies, and one of the things we realized was that there was a relatively sizable amount of tech debt in our data pipeline, and we really needed to improve the overall performance of our data warehouse in terms of speed, accuracy, cost, etc. And so I reached out to Pedro, who I've worked with before, and knew that his team, he and his team could really help us in implementing DBT best practices and help solve our technical challenges. So today we are here to basically walk you through one of those technical challenges that Pedro and his team helped us solve. So let me start first with some business context about our company. So Metropolis Technologies is North America's largest operator of computer vision based parking technology. And our value proposition is basically seamless parking. You drive in, your license plate gets recognized through our computer vision technology, and if your payment info is on file, basically you don't have to do anything more. You basically just drive out, and our technology will auto charge you. We'll know how long you were there. You'll just get charged automatically. So it's really seamless drive in, drive out technology basically. So that's our value proposition. And just to give you like a little bit of a demo of our product in action, video please. Do I just hit? Okay. All right. So as I was just saying here, you basically just drive in, and we have cameras that can scan your license plate and your vehicle, and you park. And if it's your first visit, you basically use the QR code that's on the walls in the facility. You scan the QR code, and there's a relatively simple, straightforward customer registration form. Basically, you fill in your form, including payment info, and you're done. That's it. And when you leave, you're going to get charged. You're going to get basically a receipt via text that tells you, how much you were charged, and you're done. Now your subsequent visits, your second visit, gets even easier. There's no longer a registration thing. You just drive in and you drive out, and that seamless product offering then is working not only in that location, but any of the 4,000 locations that are part of our network. So it makes it even easier over time for you. And so that's our overall value proposition. So let's first talk about, what was the business problem here that we wanted to solve. So as you just saw in the demo that I just showed, a key critical step is for a user to register on their first visit. And that puts them on the happy path for them in terms of product onboarding. If they've done that, then everything works fine. They have a great experience, and the company gets revenue and so on. But if that step is missed, then it's no longer a happy path. The user has a not so great experience, and the company has revenue loss. So that was really the problem, and I'll just go back here to talk about like exactly what the question then came for us. It was really, how do we increase the registration rates while people are still in the parking lot, because that's their first visit. And so what we saw when we looked at the data about how we can improve the registration rate is, firstly, if you look at the chart on the left, what we saw there was that most visits are relatively short, about an hour long. And also, if you look at the chart on the right hand side here, what you see is that a really large segment of people, over 80%, basically register within 15 minutes of them pulling into the lot. So for that large segment of people, we really don't need to do anything. There's no intervention needed. They're on the happy path, they're registered, everything's going to work fine. So it's really the remainder. And for those folks that don't register within 15 minutes, what we've seen is that there's a very high likelihood that they're not going to register, and then that puts them into like a not so happy path where an intervention is needed. And intervention could be things like somebody as part of our operations team going and putting an additional flyer on their windshield or something like that to help them do the registration. We also have a couple of attendants on the lot, so we can actually help people do registration. So that was really the challenge. And from a technical standpoint, the data standpoint, it was really, how can we identify unregistered users within minutes of them pulling into a lot, basically. So I'll let Pedro now walk you through how we tackle that challenge.
Okay, so that was the key challenge, the key question. How can we identify these drivers quickly? And can we? And at the time, when we started the project, we could not. We had this legacy pipeline that Kieran was talking about, was taking over a couple hours to refresh. So the latency wasn't good enough for the use case. We also have this situation where Metropolis acquired a larger company and it's migrating all these parking locations into the new system. So we have data increases that are coming from new garages being onboarded. So that makes the pipeline even slower over time. And then there have been some attempts to improving the speed of the pipeline that were not successful. I'll go into that a little bit. So then the question is like, okay, what do we do at this point? What options do we have? So before I get into the technical aspects, I'm going to show you high level, like the data flow and the architecture. Metropolis system is based on a couple of operational databases, Postgres and MySQL. And they're using Amazon data migration service to sync the data using a change data capture process. So for every update or insert in the source system, a new record gets written into S3. And then from there, we have a Snowpipe that loads the data in near real time. And then from there, dbt transforms the data, creates the data assets, and those are distributed to the consumers via Tableau and other operational systems. So the CDC is very practical because we get every single update, but at the same time it poses some challenges because we have to process, essentially multiple records per what would be a single record normally. So when we started this project, then we have a few decisions to make. So the first one was, what technologies can we use? We had this pipeline that was taking too long. Can we use this pipeline, or do we need to switch to something else? If we kept the pipeline, then the question is like, okay, what changes do we need to make, and how do we make the changes? Do we refactor incrementally, or do we rebuild the whole pipeline? And then finally, it's like, assuming that we got all this under control, then what's a good pattern to update the data, process it efficiently and cost effectively? So I'm going to go through each of these decisions that we made. The first one was whether we could keep dbt and Snowflake, or do we need to introduce other technologies? So when we analyzed the use case, we found that the latency needs were actually in the order of minutes. Like Kieran was talking about, we want a person to actually go and take an action, maybe put a QR code on the window. So we didn't really need like sub-second latency for this use case. So this was an indication that we could stick with our current stack. Then there was also the consideration of the team capability. So we already had, even though Metropolis has data engineers that could have supported the streaming architecture, we have an analyst team that was familiar with dbt and Snowflake. And then this team knows the product very well, they know the business rules. So it made sense for them to continue to contribute on that pipeline. And then the last consideration was one of simplicity. So we already had this infrastructure that's not too complicated. So we said, well, can we keep it like that? Avoid introducing another component to the stack. So with all of this, we felt pretty good about sticking with dbt and Snowflake for the use case. So then the next question was like, okay, what changes do we need to make? How do we make this happen? So we thought about refactoring incrementally in the beginning, But after looking into it more deeply, we saw that it wasn't practical. The pipeline had accumulated some technical debt. Some of the issues that we had in the pipeline was limited testing. There were also like coupled concerns. So you have like multiple entities that are being refreshed or processed, in the same model. This actually resulted in unclear grain sometimes, so we didn't know exactly what the grain was supposed to be in the model. And also some code duplication. So when we took it into account, all of this, we said, what if we just rebuild? And then if we rebuild, it had a couple of other benefits, which, one is like we can process entities independently. So that makes the pipeline more scalable, not only from a performance perspective, but also from giving us the ability to add new concepts or react to changes in the product. And then also, it enabled this type of use case that we're discussing today. So the third design choice is like, okay, how do we make this happen? So one of the challenges that we had is we needed to update a large model relatively frequently, and that depends on very large sources. And the sources are independent, so they get updated independently. So if you look at the image here, we're trying to create a transaction level table, and a transaction represents a parking visit. So we have a visit level table that includes data from the transaction stream, but also from camera events, vehicles, subscriptions, and so on. We have a number of these streams that need to be combined for us to apply the rules. So then the question is like, how do we do this efficiently using DBT and Snowflake? So we came up with this pattern, multi-entity incremental process. That's what we ended up calling it. And in this part of the presentation, I'm going to talk a little bit more about that, how we implemented it. So what we tried first, we first developed table models, full refresh models. They're usually the best starting point. You don't have to reason too much about the incrementality aspects. They're relatively simple to write and test. And they also serve as a baseline for you to improve the performance over time. So we did this, but we knew that this wasn't the solution. They're slow to run. They always process all the data, historical data, so they become wasteful and expensive. We also consider views, but then what happened is like the views would have to do these large joins on the fly, like large time series tables being joined on the fly every time we had to query it. So the response wasn't very good, and also it became expensive. We were excited about trying dynamic tables in Snowflake. So conceptually, you define the logic, and then Snowflake figures out how to do the processing efficiently. But what we found is the dynamic tables were taking as long as a full refresh. So this wasn't a viable solution for this. And they're also less flexible than regular tables. So we kind of quickly pivoted away from those. And then the incremental approach, the traditional incremental process, is usually single source, single table. So that wouldn't serve the use case where we had these multiple streams. So this is where we evolved that approach into this multi-entity incremental process. So what does that look like? So here on the left, we have the typical single incremental traditional process where you identify new, let's say in this case, transactions or updated transactions, and then you simply upsert those into the destination model. And then on the right, we have the contrast, which is the multi-entity. So the first part is relatively similar. You still have to identify what transactions are new and which transactions have been updated since the last time you ran the model. But you also have to look at the related entities. So in this case, we're showing only one entity, an events entity, but they can be multiple. There are multiple. So we also have to find what are the events that got updated or inserted since we last ran the model, and how are they linked to the transactions that we need to update. So once we do this, then we identify a subset of transactions that are impacted, that need to be reprocessed. And then from that point onwards, we simply enrich with in this case, the transaction data with the event data, and then we can do the upsert into the final model. So now I'm going to show you some code so that you can see how we implement it in practice. So the first code section here is simply the traditional incremental model. Relatively simple. At the bottom, you see in the conditional incremental block, we have we're selecting the transactions that were updated after the last time we ran the model. So relatively straightforward. And then now I'm going to walk you through the other pattern, the multi-entity. So since it's more complex, I'm going to go step by step. So the first step is relatively simple. We still have to find when was the model updated last. So that's what we did in this first CTE. Then the second step is also similar to the traditional approach, where we find, okay, what are the transactions that we need to reprocess? So here we're identifying those transaction IDs. And then the third step is where the related entities come into play. So here we're looking at what are the events that got inserted or modified after we ran the model last time. And then what are the transaction IDs that are associated with those. And then we create a union of those, and then we come up with this set of transactions that need to be reprocessed or processed if it's the first time. And you see that the whole thing is wrapped in the incremental conditional logic. So when we're doing a full refresh, we don't have to do this section. This is all only done when we're doing incremental processing. And then once we identify the transactions that we need to upsert, what we do then is we go back to the transaction table, and then we pull all the data for them. So it may seem like redundant, like why not read all the transactions before, and why do you ref the int model again here? And there's a performance reason, and there's a good article written by the guys at Select, where they explain, sometimes when you access the same CTE twice in the same model, then Snowflake has to materialize that CTE, and it becomes like really slow. So we typically use the import CTE pattern that DBT Lab teaches, but in this case we had to refer to the transactions again. And then here you will notice that this model and also the source are clustered by transaction ID or something correlated with transaction ID. So this scan is very fast. So we're looking for those transactions that got upserted and modified recently. And transaction ID is an integer, so it's correlated with time. So that's the last step that we're showing in this slide. Number 4, finding the upsorted transactions. And then continuing on this slide, once we know which transactions need to be updated, all we have to do then is we have to enrich. So we enrich that with, in this case, the events. In our real use case, we have multiple streams. One thing to note here is you have to keep track of the timestamps. And for simplicity here, we're showing a simple combination of the timestamps. But in reality, depending on how your ingestion works, you may need to keep track of the timestamps separately. So this is the last ingest time for the transaction. This is the last updated time for the events, and so on and so forth. One of the things that we are testing is the possibility of using streams. There's a custom materialization that someone wrote, it's open source, that uses Snowflake streams. So we're going to be testing that more thoroughly and see if we can replace this type of logic with the streams approach, which is makes it simpler because we don't have to reason about time and when the data got inserted and if we had late data and the lookbacks. And so we simply can read the stream, and then that will give us like the new data that got modified or inserted. So from here, I'd like to hand it over to Kieran to talk a little bit about the impact of the project and the results.
Great, thanks, Pedro. I guess this is where I get to take credit for all the great work that Pedro and his team have done. So first of all, the latency of our pipeline improved dramatically from over 2 hours to less than 5 minutes, basically. And that was key to enabling and solving the business problem that we kind of started this conversation with, right? We really needed to know in minutes if somebody was in the lot, and this really solved it. But in addition to doing that, it brought the cost down of the pipeline by more than 90%, per execution, per run, basically, because it was so much faster, right? So our cost was now like 10% of what it was before. We did have to run the pipeline more frequently, again, to to enable the business cases. So we could now run the overall pipeline like 16x times, as frequently as we were doing before. But even factoring that, taking that into like account, our net cost reduction was still like 50%. So we're getting something that's better, faster, and cheaper, basically. And so really splendid results, helped us a lot. And in addition to like these results you see here, it also kind of unlocked a couple of like strategic wins for us. So our business model is we are a parking technology operator. We have we are both a product and we are an operator. And we operate our technology for large real estate holding companies, basically, like very large real estate holding companies that own like portfolios of parking garages all over the world, basically. So oftentimes for us, the way we grow is really sales opportunities. We go to them and we pitch our product, etc. So often there are like RFP needs where they say they want real-time reporting or near real-time reporting. So this business case even, this particular solution basically unlocked those opportunities for us. So it's like a huge growth driver for the business. And as an analytics data science team, there are plenty of other like I would say use cases, analytics use cases, where if you have a low latency pipeline, near real-time data, you can unlock a bunch of insights. So I think overall, lots of things that this actually unlocked for us. And even from a data strategy, data team perspective, there were a lot of like technical takeaways from this exercise, and I'll let Pedro walk you through those.
So the first one was, your stack can do more than you think sometimes. So before you try to get more complicated or fancier, think about, can you use your technology differently? And DBT is a great framework. It's extensible, so you can build on top of it. And then, the data platforms are being improved all the time, right? So really think hard about it. Like, do you really need more moving parts in your stack, or can you meet the needs with what you have? The second one was like, even if you had this complex processing that we talked about, you can still do it incrementally. You can still do it with DBT. It becomes a little bit harder to reason about, and admittedly it's more complex. But in this case, we're not introducing any custom materialization or anything like that. We're using the DBT primitive, so they're well tested, well understood. So it is, it's a very practical approach. Then the next one is when you have technical debt, our inclination is to refactor, right? We think about the investment, all the things that we have, but sometimes it's actually better to rebuild. And I'm not suggesting that you throw away what you have necessarily, but you may want to rebuild parts of your pipeline. So instead of trying to, let me improve this model, take a step back and say, okay, what am we're trying to do here? Is there a better way? How should we structure things? So, and this kind of leads into the next one, which is like, don't delay the best practices. So we see it a lot where, you're rushed to implement DBT, you have a lot of pressure from the business, you need to do things fast, and then you start kind of cutting corners, right? Putting to do, and you may not get to those. So take a step back, invest in proper architecture in the beginning. If you're new to DBT, talk to people who have implemented it, be part of the community. It really makes sense because this is something that compounds over time and comes back and bites you really in different ways. So some are kind of obvious, like the issue we had here, the pipeline running long and spending more money than we have. But there are some other that are a little bit more subtle. You may start getting duplication of code. You may start getting data quality issues. It's harder to onboard new team members. They're afraid to touch the code base and break something, so they may write new logic somewhere else. And then at the end of the day, you may start losing trust from your stakeholders. So that's the hardest thing. Sometimes you can do everything right, but you have one little thing, and then that kind of defeats or undoes some of all the goodwill that you work hard to develop. So don't underestimate this part. I mean, really invest in the best practices. It really makes sense. It's going to save you time. Your velocity is going to be much higher later on. And then the last one is kind of like a conclusion of the overall project. It's like the analytics engineering teams, have access to tools today where they can create a lot of value for the business. So something that maybe a few years ago was impossible. You didn't have the technologies, now you do. And you can create a lot of value without having to introduce a lot of complexity in your stack. So with that, I would like to thank you and open up for questions.
A couple questions. One is, did you take a look at Snowflake hybrid tables?
The question is if we took a look at hybrid table for performance. No, we did not. All the platform was writing into Postgres or MySQL, and since we had the data already flowing, we simply used the regular tables.
Regular Snowflake tables, yeah. I think the hybrid tables allow you to do indexing for better performance. That was just a question.
Mm-hmm.
And then the other, how do you take action on, let's say, when someone has been on, when someone hits that 16th minute and they haven't registered yet? Do you have a process that takes action on that?
Yeah, absolutely. Yeah, so there are quite a few interventions that we can do, and the idea here is that with the help of our data pipeline and all our data stack, there are like now near real-time dashboards, like operational dashboards, that the operations teams can use. So the way our business works is like, again, we have these garages we operate. Most of the technology is automated, right? So, but there's like minimal staffing in these places, 1 or 2 folks. But they are then looking at all these screens, basically, the dashboards and so on. Exactly. Exactly. Yeah. Yeah. Then they can walk around. They can put a flyer on the windshield, talk to the person if they see the driver there. Things like that.
Any other questions? Well, if not, we'll stick around a little bit longer if you want to talk to us in private. But thank you again for coming.
Thanks, everyone.
And here's our contact information. Appreciate it.